Use the limit method to find the horizontal asymptote for this function. We have a rational function, 3 minus 2x over 3x squared minus 2x minus 1. All right, since we are in calculus, right, I mean, there's a pre-calculus way to find horizontal asymptote, but in calculus what we want to do is we want to find the limit as x approaches infinity of this guy right here, right? We got 3 minus 2x over 3x squared minus 2x minus 1. All right, so the first thing we want to do is we want to look at the denominator and see what is the highest power, right? Well, it's the x squared, that's the leading term. So we want to divide everything, right? So all of these 5 terms, we want to divide everything by x squared. So we still have the limit. If you don't write it each time, that's fine, right? But we're going to just divide everything by that x squared, okay? So yeah, a lot of writing that we got to do here. So everything is going to be divided by x squared, and then we're going to simplify. Okay, we should see some of these terms canceling out. Okay, so just writing everything each step along the way. Of course, nothing can cancel out here, right? So we just 3 over x squared. Okay. Here, one of the x's can cancel, so we get 2 over x. On the denominator, you notice x squared divided by x squared is just 3. Here we get just 2 over x, and the last term is just 1 over x squared. Okay, so everything is simplified now. And so the last thing that we're going to do is we're going to use the limit laws, and we're going to take the limit of each term separately. Okay, so the limit as x approaches infinity of 3 over x squared. Hopefully we should be able to determine what that is, right? And then the limit as x approaches infinity of 2 over x. All of that divided by, and then same thing on the denominator, right? We're going to take the limit as x approaches infinity of each of these 3 terms, right? So limit as x approaches infinity of 2 over x, and the last term here, the limit as x approaches infinity of 1 over x squared. Okay, what happens in each of these 5 cases, right? What's going to happen here? Well, this is just a rational function. There's no x in the numerator, right? As x gets really large, this fraction is just going to get closer and closer to 0. All right, so this limit is going to equal 0, right? That's just the basic property of the rational function, right? So 3 over infinity is a real small number. We'll call that 0. Same thing. 2 over infinity is just a real small number, 0. Okay. Limit as x approaches infinity of 3 is just going to equal 3. And similarly here, we're going to get 0. And 0. So in this case, 0 over 3, which is just equal to 0. Right? So what does that mean? It means that the horizontal asymptote is going to be the line y equals 0 in this case. Now back in Math 126, how do we determine this? Right? We looked at the power. Right? The degree of the numerator is 1. The degree of the denominator is 2. So the degree in the denominator is greater. So in that case, the horizontal asymptote will always be the line y equals 0.